Okay, so this is the vectors of the Year 11 revision booklet. Question 1, the diagram shows a regular hexagon A, B, C, D, E, F with centre O. What we need to know, regular hexagons, all the sides are the same length, all the angles are the same size, and actually if we cut it up, we can cut it up into 6 equilateral triangles. So these lengths are the same as these lengths, and in fact these lengths are parallel, and these lengths are parallel, and these lengths are parallel. Okay, so express it in terms of A and or B, AB. So we want to go from here to here. So we're going to go the wrong way down 6A, so that's minus 6A, and the right way up 6B. So that is 6B minus 6A. Now it wants us to do E to F. Now E to F, like I said, is parallel to the 6A, and they're going to be the same length, so it's going to be 6A. Okay, X is the midpoint of BC. Express EX in terms of A and or B. So we're going boop all the way around to here. So let's work out what BC is first of all. BC is going to be 6A, so BX is going to be half of that. It's minus 6A and minus 3A. Okay, then we can try and go from E to F to A to B and then to X. So we can go from E to F, we need to get from F to A. F to A is going to be 6B, because it's parallel and going in the same direction. So we are going to add E to F, which was 6A, to F to A, which is 6B, to A to B, which is 6B minus 6A, and B to X, which is minus 3A. Then it's a question of collecting like terms. So first of all, let's deal with our A's. We've got 6A minus 6A minus 3A, so that's minus 3A in total. And then we've also got plus 6B plus 6B, so that's 12B. So in total we've got 12B minus 3A. So y is a point on AB extended such that ABBY is 3, 2. So y is going to be over here somewhere. Deep, 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 deep. And this is going to be length 3, this is going to be length 2. Prove that EX and Y all lie on the same straight line. E, X and Y. Okay, so we know how to get from E to X, we've just worked that out. What would be a good idea now is to work out how to get from E to Y. So we know, well, we're going to have to work out what BY is. Well, we know that AB is, we worked that out earlier on, AB equals 6B minus 6A, and BY is going to be 2/3 of that, because this is length 3, so this is the whole length, this is only length 2, so it's 2/3. So that's going to be 4B minus 4A. And then if we try and get from E to Y, then we are going to have to do, well, E to F, which we worked out was 6A. Then we're going to have to do F to A, which we worked out was 6B. Then we are going to have to do A to B, which we worked out was 6B minus 6A. and then we are going to have to do b to y, which was 4b minus 4a. So now if we simplify again, a terms, we end up with minus 4a. B terms, we end up with 612, 16b. Okay, so what we've now got to do is, I'm just going to go back to this one up here, and I'm going to factorise it. If we take out a factor, they've both got a common factor of 3, the 12b and 3a. So we could also write this as 3 and then 4b minus a. And then for this one, I'm going to factorise this one as well. 16 and 4 both have a factor of 4, so it would be 4b minus a. And because they've both got the 4b minus a in brackets, they've both got a common factor, so they are both parallel. And because they both use the same point E, they both start at E, then we've got that they are on the same line. They share a point, and have a common factor of 4b minus a. Okay. T is the point on PQ where PT and TQ are in a ratio 2 to 1. So PT, TQ, so that's 2 to 1. OPQ is a triangle, OP is A, OQ is B, right down in terms of A and B, PQ. So to get from P to Q, we are going to have to do minus A plus B, or B minus A. Express OT in terms of A and B. Well, first of all, we need OP, which is A. We also need PT, which is going to be 2/3 of PQ. So it's going to be 2/3 B minus A. So then if we want OT, it's going to be those two things added together, A plus 2/3 B minus A. It wants it in its simplest terms, so I'm going to expand out the brackets, and to make things easier, because everything's going to be in thirds, I'm going to turn A into thirds as well. So that equals 3A over 3 plus 2B over 3 minus 2A over 3. We've got our like terms for A again. So we end up with A over 3 plus 2B over 3. And we could take our factor of a third for each of those if we really wanted to. So we could do 1/3 A plus 2B. OABC is a parallelogram. P is a point such that AP is equals 2/3 of AC. So that would be 1/3 therefore. OA is 6A, OC is 6C. Find the vector OP. So first of all, I think we're going to have to work out what AC is. To get from A to C, we're going to have to do minus 6A plus 6C, or 6C minus 6A. AP is therefore 2/3 of that, so that's going to be 4C minus 4A. Then if we want to go from O to P, we're going to have to need to know OA as well, which is 6A. Therefore OP is going to be OA plus AP. We've got our like terms for A again, so we can simplify that to 2A plus 4C. Okay. The midpoint CB is M, so we're going to have an M there, which 1 to 1. Prove OPM is on a straight line. So we're going to have to work out how to get from O to M. Before we can do that, we're going to have to work out what BC is. Well, because it's a parallelogram, BC is parallel to AO, and we're going the opposite way, so that's minus 6A. Then BM is going to be half of that. Okay. Then we are going to need to get from O to M. So we know that OA equals 6A. AB, again it's a parallelogram, so it's the same length and parallel, so it's going to be 6C. So therefore OM is going to be OA plus AB plus BM, which is minus 3A. Then we've got some like terms to collect again, so we could rewrite that as 3A plus 6C. I'm going to go back now to this one. We can factorise this again, so we've got a common factor of 2, and I can factorise this one. We've got a common factor of 3, and again we know that they are parallel because they've both got A plus 2C, and we know they're on the same line because we've started over them. Okay, OPQ is a triangle, R is the midpoint, so that's split in 1 to 1. S is the midpoint, OP is P and OQ is Q. Find OS. So we are going to need to find, we can go either way, I'm going to go from O to P to S. So to do that we need to know that PQ equals, well, we're doing minus P plus Q, or Q minus P, and therefore PS is going to be half of that. Then all we need to do is go from O to P, which is R, and P to S. So we are going to do P plus half Q minus half P, which gives us half P plus half Q. We can factorise that if we want to, so we end up with half P plus Q in brackets. Show RS, RS, line that's not there, is parallel to OQ. So we need to be able to go from O to R and then R to S. We can go from O to R, that is going to be half P, and then we are going to have to work out how to go from R to S. Well, we know how to go from O to S, so R to S equals O to S minus O to R, because we don't want that little bit. So that is half P plus half Q, and then we're going to take away from that half P, which leaves us with half Q. And we know that they are going to now be parallel, because this is Q and this is half Q. So if we have to factorise this, yeah, they've basically got a common factor of Q.